Yeah, hi students. A very good morning, everyone, and welcome once again to Om Institute. And welcome to this practice session, the PYQs practice session on control system for the upcoming BHEL 2025 examination that is going to be conducted in the next week. Very good morning, Ajay. Good morning, Sai Vikas. Good morning, Ramu. Good morning, Sita. Good morning, Akhil. Right. Okay. Come on, update all your friends that the session is live so that everybody joins quickly, and let us get started. Okay, with the fundamental practice. So the idea is, to exactly get you familiar with the PYQs of, firstly this particular subject, that is control systems. Okay, and later on, yes. Come on, update all your friends that the session is. Yeah, and later on, as I'm telling you, if you feel that these sessions are useful, I'll plan for more subjects as well. Correct. Okay, dear. So let's get moving ahead. Let's get started. Important updates for you. Yes, guys. Yeah. On the Ugadi, on the festive occasion of Ugadi, the Om Institute has brought to you a flat 20% discount on all the Om online courses, live as well as recorded. Yes, you just have to use the code, okay, Ugadi 20 to avail this discount, and this is going to be applicable till 5th of April. Okay, this offer is applicable for all the online courses, I repeat, live as well as recorded. Okay, and the offer is applicable till 5th of April. Right, dear? Now, let's get started with the first question. Okay, let's get started with the first question on your screen. Here it is. Okay, so miscellaneous questions. Okay, so miscellaneous questions will be there. Courses, I repeat, live as well as recorded. No, sound is absolutely fine, Vikas. Maybe try to increase the volume of your system or mobile. Okay, volume is totally fine. I've just checked it up. Okay. Right. So in the Bode plot, if the value of the face, okay. So, I instantaneously planned this particular session. Okay. I instantaneously planned this particular session. So I don't have the questions properly typed. They are mostly screenshots I've taken from the previous BHEL paper that I had. Okay, so I'll keep reading that along with that. In the Bode plot, if the value of the phase at gain crossover frequency, okay, so what they are trying to tell you that at gain crossover frequency omega g, okay, the phase is given to you, okay, angle gj omega g hj omega g, okay, is minus 125 degree. What is the value of the phase margin of the system? Simple question it is. What is the value of the phase margin of the system? Come on. What is the value of the phase margin of the system? Okay, so a very basic fundamental question, and most of the questions you will find to very fundamental level. Okay, so as you know, in BHEL there are total 240 questions, okay, to be solved within 150 minutes. So a lot of questions and very less timing is there. So most of the questions you will expect straightforward. Okay, so phase margin is given by what? It is given by 180 degree plus angle gj omega g hj omega g. The phase at gain crossover frequency is required. Okay, and hence your answer is straightforward. It is just a mind calculation. 55 degree, option number A, totally correct. 55 degree, option number A, totally correct. Yes, correct, Sai Vikas, correct, Ramu, correct, Teja. Okay, simple question it is, I would say. Next one. If poles are more than GS, if poles are more than zeros, okay, in GS, then the number of root locus branches. See, the number of root locus branches is given by max of P comma Z, and what they are telling, poles are more than zeros in the GS. Then the number of root locus branches, very direct question. The number of root locus branches, max of P comma Z, clearly mentioned P is more than Z, where P is the number of poles and Z is the number of zeros. Okay, so answer will be how much? The number of root locus branches will be equal to the P, that is the number of poles. Option number B, you will tick mark here. Simple, na? Option number B, correct, Teja. Simple one only. Right. Okay. Correct, Sai Vikas. Then I have the next question for you. Okay, so look into this block diagram. What will be the natural frequency omega n for the above controller? Okay, Kp into 1 plus STD. You should be able to say what controller is this. Okay, this is the PD controller. You should be able to say that this one is a PD controller, correct? Okay. Right. In fact, on the controller, there are more questions. I'll jump to that directly, or we'll take it step by step only, not a problem. I think around controller, yeah, there is this question here as well, here as well, here as well. Okay. Correct. Right. So have a look into this. Okay, what is the natural frequency? So let me just directly write down the characteristic equation. Okay, what is the characteristic equation? Normally we write it as 1 plus GSHS equal to 0. HS feedback here is unity. Okay, so 1 plus Kp, 1 plus STD. Okay, whole multiplied by 1 by some JS square. This is your GS. HS is 1. Unity feedback is given to you. Now, if I simplify, let me multiply JS square actually. So, JS square plus SKP TD plus the constant part Kp equal to 0. Let me divide by J. So that to start with the standard form S square. So, S square plus S Kp TD by J plus Kp by J equal to 0, and now you have to compare it to the standard form, S square plus 2 zeta omega n S plus omega n square equal to 0. They're only asking omega n. So what is omega n square is Kp by J. So omega n is root over the Kp by J, and that is option number B. That is the option number B. Correct, dear? That is what is here, the option number B. Yes, option number B is the correct for this one. Yes, dear. Right. Okay. Moving ahead to the next question then. Let me move ahead to the next question. Okay. Our system is set to be slightly blur. We'll see how it is coming here in the mobile also, but no problem. Our system is said to be completely controllable if it is possible to transfer the system state, okay, from any initial state x of t naught to any desired state xt in the specified finite time, by a control vector, ut. Okay, you can also try to read it, but I am reading it parallelly. Okay, a system is said to be completely controlled. This is a definition of controllability. There is not on test. There was one question on test of controllability also. We'll come to that. Okay, but this is on what? System is said to be completely controllable if it is possible to transfer the state from any initial state up to any desired state by what? By the application of a control input within a specified time. So true. This part is true. Then next is on the definition of observability. A system is said to be completely observable if every state x of t naught can be completely identified or observed by measurement of the output yt over the time 0 to infinity. Now again over a specified finite time. Again it should be over a specified finite time, and that specified finite time could be any value of time, but some specified finite time. Okay, so this is partially only correct. Okay, this is partially only correct. Okay, that yeah, partially the definition is true. The system is observable if every state can be observed by measuring the output, but over a desired finite value of time. Okay, right. So hence statement number 2 is not completely true. The statement number 2 is not completely true. It's option number A to be tick marked. Okay. So you have to be very careful in reading the entire statement, especially if it is, a theory question or a definition based question, correct? So we'll mark it as option number A. Right, dear? Option number A. Okay. And moreover, okay, that specified time could be anything from minus infinite to infinite. That also can be specified here. Okay, so for that point of view, the statement number 2 is not completely true. Okay. Right. Moving ahead to the next question. Which of the, very simple question, just tick mark and move away. Which of the following gives over only, if it is about only absolute stability criteria, RH criteria. RH criteria, done. Right. We know that this is a simple one. Laplace transform of direct question again. Unit parabolic function. What is a unit parabolic function? Half t square. And it has the Laplace transform 1 upon s cube. Okay, half t square occurring at t equal to 0 means half t square ut, you can say. The Laplace transform is 1 by s cube. Direct formula question. Okay, so there is no thought. Direct formula question this is. Okay, 1 by s cube for parabolic function. Okay, because what is the Laplace transform formula for t power n? It is given by factorial n divided by s raised to the power n plus 1. Correct na? Yeah. Next question, again direct. For the feedback control system of type 2, what is the error for ramp input? So if it is type 2, okay, what is the steady state error? For step input, 0. For ramp input, also 0. Okay, it will give a finite non-zero error only for parabolic. Parabolic goes with type 2, and that is, it will have the steady state error 1 upon Ka, where we know Ka is the acceleration error coefficient. So for step input or ramp input, if the question is, answer is 0. Option number B, finish. Okay. Correct, na? It is 0. Done. Yes, correct, Sai Vikas, correct, Ramu. So this one. Many questions are actually direct, okay? Many questions are direct. If the poles of closed loop systems are complex with positive real parts, okay, if the poles are complex with positive real part, I mean poles are something of this kind, okay, complex with positive real part, okay, so you know, generally the poles are given by minus zeta omega and plus minus j omega and root 1 minus zeta square, but they will be positive, they will be complex but with positive real part, right? If zeta, okay, imaginary part will spill with the real part will become positive, okay, and then the system is what? Anyways, if the real part is positive, or sorry, if the poles are in right side plane, the system is unstable, okay, so output has to be exponential growth only, okay, exponential decay, not at all possible because it's an unstable system condition, okay, the output is exponential and oscillatory increase. Okay, the output is exponential and oscillatory increase. Yes, it can be only exponential increase. Okay, it can be only exponential increase without oscillation if you have zeta lesser than minus 1 as well. Okay, or zeta further lesser than minus 1. Okay, less than or equal to minus 1 also can be put here. Okay, but for zeta up to minus 1, it is exponential with oscillatory increase. This is how the output waveform is for the zeta between 0 to minus 1. Correct? So yes, it has to be option number B here. Correct? It has to be the option number B. Determine the gain at the break point for the open loop transfer function GSHS equal to K upon S plus 1. Simple question. Simple question. But I have a suggestion to give here. It's a simple question, but I have questions. It may be possible that you are not even able to see all the 240 questions, okay? Hello, is the video stuck or what? No, it's fine. Yeah. So it may be quite possible that you even are not able to see many of the questions, okay, because the timing is less, 150 minutes and 240 questions are there. Okay, or even if you are able to see by chance all question, maybe not every question you can solve within the specified time. Okay, so what I will suggest you, any question which is easy also but requires some calculation, you can mark it. You know what is breakaway point, simple. Just some calculations are required. But maybe it is possible that the time that I spent to solve this question, maybe in the same time I'm able to solve two direct questions. It may be possible. It may be possible. Okay, so just, you know, push it till the end. I don't say ki, don't take it something as ego ki, okay, this is a very good, very simple question, I should be able to solve this. Okay dear, you know you can solve it. Okay, but what you have to prove in the exam, you have to prove that you have solved maximum correct questions, okay, rather than showing, okay, I can solve this breakaway condition question. No. So that is what my suggestion is. Okay, at the end, if you feel the time is left and you have marked this question for review, then go and then jump and then solve it. Okay, that is what my honest suggestion is for any such examination. Clear? Okay, so please follow that in the exam as well. Okay, you may gain some benefits. Now coming to it, what is the breakaway point first of all? Okay, for the breakaway point, okay, first, okay, let me write down the characteristic equation. What is my characteristic equation? 1 plus GSHS equal to 0. GSHS equal to K upon S plus 1 equal to 0. Okay, from the characteristic equation, we write down K as a function of S. So K would become minus of S plus 1. That is minus of S square plus S. Correct? And then what is dk by ds? Okay, breakaway point. What is dk by ds? Minus of 2s plus 1 equal to 0 and s equal to minus 1 by 2. Okay, s equal to minus 1 by 2. Okay, could be the breakaway point. Okay, right. So even if I draw both the poles here, okay, one of the pole is at 0, one of the pole is at minus 1. So of course the breakaway point is expected between two open loop poles. Okay, one of the branch will start from here, one of the branch will start from here. So yeah, minus half is a valid breakaway point, because what we know now that every solution of dk by ds equal to 0 may not be breakaway point. For it to be a breakaway point, it must lie on the root locus. It must lie on the root locus. Yeah, so this is a valid breakaway point. Correct. Now, if it is a valid breakaway point, question is asking what is the gain at the breakaway point. Okay, breakaway point is a point lying on root locus, and if any point lies on the root locus, you can satisfy magnitude criteria. See, I have proved you that this point will lie on the root locus. That is what I have proved you first. Okay, so what is that magnitude criteria? What is that magnitude criteria? I'll put down the magnitude criteria mod GSHS equal to 1 at that point. Okay, at which point? At s equal to minus half. Okay, so mod GSHS, that means magnitude of k upon s. S is minus half. Again, s plus 1 minus half plus 1. This should be equal to 1. Solving which, this is also half, 1 by 4. When you take magnitude, negative will go away. So k should be 1 by 4. K should be the 1 by 4. And that is option number A, 0.25. 0.25. Now see, now you see the difference here. Now you see the difference, automatically you see the difference. For many of the previous questions, by the time I complete, I am getting some comments. Okay, for this question, I've got just one comment, that also not the correct answer. Okay, that is also not the proper correct answer. Okay, so you just have to be careful about that. That's what I'm telling in BHEL exam time. The timing is very less per question. So wherever, although it may be simple question, for GATE point of view, this is a very simple question, I would say. Okay, but again I repeat, if any question requires some calculation, push it at the end. If end you have time, solve it up. Because it may be possible that in the same amount of time that you have solved this question, maybe you solve 2 or 3 direct questions. Every question is of equal mark. It's not like this is a 2 mark and other is 1 mark. Every question is of equal mark. In the same time, you could have solved 2 to 3 questions. So again, push it at the end. Don't skip it. Let's see. If it may be possible that after seeing all direct questions, you have the time at the end, then go for it. But first, make yourself in the safer zone. Okay, that is what I will suggest to you. In the safer zone. Right. A system is given by GSHS equal to k by s, s plus 2, s plus 4 and hs equal to 1. What is the value of k for stability? Simple, cubic. It's going to be, if you know the cubic shortcut, very simple one. Okay. So can we take magnitude for s plus 1? You have to take magnitude of entire GS, not only for s plus 1. It has to be the mod of GSHS. Right. Even if you take the magnitude of each and every term, this is half, and that is why this is half of 1 by 4. Is that what you want to say, Sai Vikas? Okay. So now see, if I complete the characteristic equation here, 1 plus GSHS, 1 plus S, 1 plus K upon S, S plus 2, S plus 4 equal to 0. So solving it, I'm getting cubic equation, S cube 2 plus 4, 6, 6S square, 2 into 8, 8, 8S, then plus K equal to the 0. Okay. Now, inner greater than outer, stability, na? For stability, okay, the cubic equation, inner product greater than outer product. Okay, inner is 6 into 8. Okay, it should be greater than the outer product, that is 1 into K. Okay, or eventually you can say that K less than 48, or you can apply the RH. This is coming from RH only. Okay. Especially for cubic equation. So K less than 48, option number C. Right? Yes, Sai Vikas. Yes, Nanendra, correct answer. Option number C, it is correct one. Option number C, it is. Next one. For a given stability error for step input and speed of response criteria, what is the most appropriate controller? Okay. For a given stability, error for step input and speed of response criteria, if all the three are of your concern. Okay, because stability means mostly PD controller can be a good choice. Speed also can be improved by PD, but PD does not impact the error. Okay, in fact, the D part may increase the error as well. Okay, so error can mostly be PI controller can be good one for reducing error, the integral part of it. Okay, if only error is the concern, P control is also helpful, but combining all three, if you want stability, error, speed, all the three to be improved, okay, then PID controller. Then PID controller is a general call to take here. The PID controller is the general call to take here. Okay, dear. Next, direct question. The transfer function, okay, of the state variable representation x dot equal to ax plus bu, y equal to cx plus du is given by what formula? C phi b plus d. Okay, where phi or phi s is the Laplace transform of the state transition matrix given by Si minus a whole inverse. In that line, option number C itself, C phi b plus d, option number A. Direct question. Direct question for transfer function formula. Okay, transfer function from the state model. Okay, next. A unity feedback system has the open loop transfer function given to you. Its root locus plot intersects the j omega axis at what? Okay, do you have to draw the root locus for this thing? Do you have to draw the root locus for this? I don't think not required. I don't think it is required, I mean. Okay. A unity feedback system has the open loop transfer function gh equal to k upon s plus 4 s plus 16. Root locus plot intersects the j omega axis. Okay, so if you want j omega cutting point for root locus, you can directly apply the RH criteria. Okay, it's not that you have to sketch that root locus. Correct, na? Okay, RH criteria. So for that RH criteria, I again need the characteristic equation. Okay, which is 1 plus GSHS 1 plus K upon S, S plus 4, S plus 16 equal to 0. Okay, so then if you solve, you will have S cube 4 plus 16, 20 S square, 4 into 16, 64 S plus K equal to the 0. Equal to the 0. Equal to the 0. Correct. And this is what? This is what? Cubic in nature. Again cubic in nature. Okay. And for j omega axis point, marginally stable. J omega axis, the system is marginally stable, and marginally stable means inner equal to outer. 20 into 64 should be 1 into k. Okay, so the system will cut j omega axis for k equal to 300 and 64 into 2. I'm sorry. So that is how much? 128, 1280. Okay, for k equal to 1280. And then, okay, when does it cut the j omega axis? At what points? Okay, so auxiliary equation will be framed up here. Auxiliary equation will be framed up here. What is the auxiliary equation? It is an even power equation. 20s square plus k equal to the 0. 20s square plus the k equal to 0. Okay. Okay, alternate terms, 20s square plus k. So 20s square plus 1280 equal to 0. So again, what is left is 20 will cancel. S square is negative of 64. And hence S is plus minus J8. S will be equal to the plus minus J8. Correct answer. S will be equal to the plus minus J8. Option number C. Yeah, correct choice. Option number C it is. The very correct choice is the option number C. Definitely. Plus minus J8. See, this all cubic equation, even in GATE exam also, the questions around cubic equation is very common. Okay. So, if I write down the general cubic equation, okay, for 2 minutes, let me discuss onto it. AS cube plus BS square plus CS plus D equal to 0. Okay, even if you feed it to the Raut array, the first two rows S cube and S square, and then we will form S power 1, S power 0. First S cube, alternate coefficient AC, S square BD. Okay, S power 1 BC minus AD upon B. Okay, last element 0. S power 0, x into d upon x, so only d will be left in 0. Okay, of course, for as per necessary condition itself, okay, I assume that a, b, c, d are all positive. Okay, so a positive, b positive, d positive, the central coefficient has to be positive. BC minus AD greater than 0, okay, for no sign change, that is for stability. Okay, because this is plus plus, it also has to be plus. Okay, so that is why I told you BC greater than AD. Okay, BC means inner, AD means outer. This is what I mean inner, this is what I mean outer. Okay, so as far as stability is concerned, okay, stable system is stable if BC greater than AD. So of course, if BC less than AD, then what will happen? If BC less than AD, this quantity will become negative, and sign change means RHP roots, and RHP roots means unstable system. The system will be unstable, and the boundary, the system would be marginally stable for BC equal to AD. But when BC equal to AD, you also get a row of 0. Okay, if BC equal to AD, S power 1 is a row of 0. Okay, and whenever there is a row of 0, we can form the auxiliary equation. How do we form the auxiliary equation? By using the equation above the row of 0. That is BS square plus D equal to 0. BS square plus D equal to 0. Right? Okay, so BS square plus D equal to 0. So from here, we can find out what is S equal to. S equal to plus minus J, because minus will come, the under root of negative number, plus minus J root over D by B. Okay. So how do you form auxiliary equation? That is important. No need to memorize even the roots formula, that you can solve. Like I've directly formed the auxiliary equation here, 20s square plus k equal to 0. Okay. So hope that is clear. Two questions we have got in the previous BHL paper on the basis of that cubic equation directly. Correct, na? Directly only on the basis of the cubic equation itself. Directly on the basis of cubic equation itself. Okay, fine. Okay, Sai Vikas, for GATE 25, GATE 26 course. Are you there in the offline batch? Okay, let's come up here to the next question first. Yeah, the initial shape of the Bode plot gives an indication of what? The initial shape is a straight line. What is that initial shape? Initial shape of Bode plot. Actually, Bode plot is built up of straight lines only by all the approximations we do. Okay, so it is a straight line. Okay, and with a slope of minus 20 n decibel per decade. Minus 20 n decibel per decade. Okay, where n is what? Where n is what? N number of poles of GS at origin. Okay, and if I assume unity feedback, this is also known as the type of the system. This is also known as the type of the system. The simple direct question again, option number D. Yes, correct, Sai Vikas, correct, Ramu, it's option number D. Okay, fine. Next. Okay, the system x dot equal to ax plus bu. I think again it has not come up properly. Ax plus bu. Okay, with a and b given to you is what? Stability and controllability. Again, I tell you that is an easy question only. Stability, though, you can say directly. If it is stability, it's a tick mark question. For controllability, you will have to test. Okay, so it's a simple question, but again, I will say it requires some calculation. So such questions again in the BHEL exam atmosphere, you should always attempt at the end. If you know you can solve it, you mark for review. At least you should know that there are some questions you can solve it up. It is going to take little bit time. I will solve at the end. So there is that option mark for review. Na? Please use that. Okay. Right. As of now, let's solve it completely. Now, it is an upper triangular matrix. Okay. It's an upper triangular matrix, but with non-repeated roots, non-repeated diagonal elements. Okay, so this particular form for controllability, I am telling you, okay, this is neither JCF nor DCF, because JCF form has an upper triangular matrix but with repeated eigenvalues. Okay, and DCF form has a diagonal matrix. Okay, so that is not there anyways. Okay, so we have to apply. We have to solve by Kalman's test, because if it was DCF or JCF, we can even think about Gilbert's test. Okay, now because it is upper triangular matrix, a basic property for any upper triangular matrix that eigenvalues is equal to diagonal elements. Eigenvalues is equal to the diagonal elements, correct? Okay, so what are the eigenvalues? Is equal to -1 and 2, and so poles. Now the poles of control system is equal to the eigenvalues of the matrix, say -1 and 2, and this 2 means RHP. So there is a RHP pole, and RHP pole means unstable. So that's what I mean, that you can look and decide. If it is a stability question, then it is a tick mark question. Okay, there are two poles, -1 and 2. This is a RHP pole, so unstable system. It is unstable. But for controllability, easy only, but a basic calculation is required, right? Okay, so we have to test controllability now. Let's do it. Okay. Yes, hi Vikas, probably towards the end of this month, you can be expecting the offline maths classes as well, somewhere around after 20th of April. Okay, you will get to know the exact details at the center directly. Okay, so yeah, now Kalman's controllability test. Okay, for controllability only is required. Okay, so what do I have? Anyways, observability cannot be assessed. For that, I need the C matrix. Okay, so the B matrix and A matrix are given to me. Okay, and then we need to form the matrix, which is a 2 cross 2 system. It is now B, A, B. In general, it goes up to A power n minus 1 into B, where n is the order of the system. But because n equal to 2 here, so we need to go up to B and AB. Okay, so B is given to me. First of all, what is the AB matrix? So multiply first row with first column, so 0 and 2. Then next 0 and again 2. Okay. So if this is done, oh, let's do it here only, no problem. So what is the S matrix? Okay, what is that S matrix? B is 0, 1 and AB is 2, 2. And what we need to check is the determinant of S, which is clearly 0 minus 2 and not equal to 0. And yes, if the controllability matrix, okay, what is this? This is what we call it as the controllability matrix. Controllability matrix. If the controllability matrix has non-zero determinant, if the controllability matrix has the non-zero determinant, is non-singular, so the system is controllable. If this was having zero determinant, then we say that the system is uncontrollable. Okay, right? So correct answer is option number A, unstable but controllable. Okay, unstable but controllable. Okay, it is unstable but controllable. Correct. Next question, ready for you. Okay, it is it is unstable but controllable. This was on state space analysis. Again a direct question. Okay, the type of the system depends on what? Okay, the number of poles of GS at origin. Okay, the poles at origin. Simple question. Okay, the question is just a definition. Many questions are definition based, as you know. What is the type of the system? Okay, next question. Okay, in the control system, the bandwidth of a system roughly measures what? The bandwidth of a system roughly measures the gain crossover frequency. See why? Because what is that gain crossover frequency? At omega, which is omega g, the mod gj omega at j omega is 1. Okay, where the Nyquist plot intersects the unit circle. Okay, or if you talk in terms of decibel scale, okay, we have 20 log mod gj omega. Let me call it as some magnitude term. In the decibel scale, this magnitude, which is measured as 20 log mod gj omega at j omega, and log 1 is 0. So this magnitude in decibel scale is 0 dB. Okay, right. So, at omega equal to omega g, it is 0 dB. It is 0 dB. So for omega less than omega g, okay, and for omega greater than omega g, it's going to be lesser than and greater than 0. Where it is greater than 0 means it is the magnifying part, amplifying part. For less than 0, it's the attenuating part. Okay, so that is what bandwidth roughly will measure here. Okay, we are interested that up to what frequency system is amplifying. Beyond that, it may be attenuating. Okay, so yeah, gain crossover frequency. The slope of the Bode plot of the transfer function Ks, let me write this one little bit more clearly. What is the transfer function? Ks upon s plus 1, s plus 10. Okay, between omega equal to 1 and omega equal to 10 is how much? Okay, the slope of the Bode gain plot, you can try to solve it directly without sketching the Bode plot. Okay, think about this without sketching the Bode plot. You can say this answer logically. Okay, please solve this, waiting for your response. Yeah, let's see. Anybody, any answer? A, B, A. See, remember that. Okay, what are the corner frequencies? Okay, what are the corner frequencies? Okay, that is, s plus 1, s plus 10. So corner frequencies are 1 and 10. Omega equal to 1, omega equal to 10, and both are due to poles. Okay, and if it is a pole, we know that slope will change by minus 20 decibel per decade. Now, what about the poles or zeros at origin? There are no poles at origin, but there is one zero at origin. If there is 1 0 at origin, dear, what is the initial slope? For zeros at origin, the initial slope is given by plus 20 m. For m zeros, it is plus 20 m. For only 1 0, it is plus 20 into 1 decibel per decade, or basically 20 decibel per decade. It is 20 decibel per decade. The initial slope is given by plus 20. Okay, now, right, that means, what is the initial part? Initial part means before the first corner frequency. For omega less than 1, that is the initial slope. Slope is 20. Okay, for now one corner frequency, as soon as a corner frequency comes, slope will change. It is due to a pole, so slope will reduce by 20. Slope will reduce by 20. So 20 minus 20, answer would be 0. Okay, let me write down more detail. For omega greater than 10, when you cross the next crossover frequency also, the next corner frequency also, the slope will further decrease. You left at 0, it will further decrease by 20, and then it will be minus 20. So anything they can ask you. Okay, right now they have asked for omega between 1 to 10. Okay, answer has to be B, that is 0. It has to be 0. B is the correct answer, not A. B is the correct answer. You have to take care that there is a 0 at origin. Correct. You had to take care about that point that there is a 0 at the origin. Correct now? Correct now? Okay. So next question. Don't have to draw the Bode plot necessarily for this. Okay. You can just about slope of different regions. Okay. You can mark it here. And now for any omega greater than 10 up to infinity, it will be minus 20 only, final slope. Next question. In a control system, the response is critically damped. Again, a tick mark question. We know that the response is critically damped if the zeta is, okay, 1. It's not properly a correct question. What I believe is it is critically damped if zeta equal to 1, and zeta means the damping ratio. To be more honest, zeta is the damping ratio. Damping factor is moreover what we call it as alpha. So we don't normally classify according to alpha. Okay, because alpha is zeta into omega n at zeta equal to 1 based on omega n. Okay, damping factor can take any value, but okay, we know the philosophy. We know the philosophy of the question, what they want to ask. So, okay, we can tick mark A at least. Okay, we know what they wanted to ask. So there is no other choice. We can tick mark A. Clear na? We can tick mark that option number A. Okay, but more clearly it should be zeta, which is defined as the damping ratio. The damping factor is alpha. The damping factor, to be honest, is known as alpha. Okay, that also is an important factor. We know everything has their own role. But yeah, anyways, moving to the next case. Which of the following is the correct comment on the stability based on the unknown k in the feedback system for the characteristic equation? Let me write down the characteristic equation more clearly. It is slightly blurred. S power 4 plus 2ks cube plus s square plus 5s plus 5 equal to 0. S power 4 plus 2ks cube plus s square plus 5s plus 5 equal to 0. Yeah. For what value of k it will be stable or unstable? Come on. Yes, come on. Everybody take this question and solve it up. Okay. Yes. See and let me know if any answer you have got. Okay. No answer yet. So let's solve it up. It's clearly on the Routh-Hurwitz criteria. Fourth order system it is. Fourth order system it is. Okay, so let me form the Routh array, starting with the s power 4 and s power 3 row. The s power 4 alternate terms are 1 and 5. S power 3 row 2k, next alternate term 5, next 0. S square. So cross multiply 2k minus 5 upon 2k. 2k into 5 by 1, 2k, 5, 0. S power 1. So s power 1 means first I multiply these two. Okay, so that is 2k minus 5 upon 2k into 5 minus 5 to 10k whole divide by this particular factor, that is 2k minus 5 by 2k. Okay, then this is 0 because the next column entry is 0 on the top, last element anyway is 0. Okay, let me actually slightly shift it. So what was these factors? This was 1 and this was 1 and this is equal to 5. This was the 2k, this was the 5, this was the 0. This was calculated as how much? This was calculated as 2k by into 5 by 2k. This was 5 and 0, and now here I write 0 because of these entries, and then last element always 0. S power 0 row, S power 0 row. So this is one particular term, this is one particular term. Now suppose this is x into 5 upon x, so 5 will be left here. This is 0 because of the right entries being 0, last element always 0. Okay, now have a look into it. First have a look into this. Okay, so 1, this is positive. Okay, 1, we start with positive, and if you want on stability, so there should not be no sign change and no row of 0. Okay, if you want the system to be stable, okay, there should be no sign change. Where? In the first column, and also no ROZ, because if there is a row of 0, we know that auxiliary equation will come and the system can be best marginally stable or worst case unstable. It can never be purely stable. It can never be purely stable. Correct? Now I can say that it can never be purely stable. Right, dear? Okay, so yeah, let me see, anybody given any answer? Yes, some answers are coming up. A, Sai Vikas and Ramu says answer A. Okay, let's check it out. Let's check it out. Okay, yeah. So now see, what is the condition required? 2k should be positive. That means k should be positive. One condition, but we have to make all the elements. Only first and last are clearly positive. Next is 2k minus 5 should also be positive. So k greater than 5 by 2. So greater than 0, greater than 5 by 2 means finally greater than 5 by 2. But there is one more third element. Okay, what is that third element? Okay, so when I multiply this actually, okay, 5, see, this is how much? 2k and this 2k can get, oh, let me solve it up completely. 2k into 5, 10k. Okay, minus 5, 5, 25. Okay, minus, this will be whole divided by 2k. 2k I'll adjust later on, that is also okay, but no problem. Even if you multiply 2k there, so that is going to be minus 20 k square. It is going to be quadratic in nature or what? Minus 5 to 2k. You can cancel this. Okay, no problem. Let me deal with this like this only. Okay, so 2k into 5, that is 10k. Okay, minus 25 minus 10k square upon 2k positive, denominator positive. So this also has to be positive because, you know, if you separate out then 2k here, this is going to be 2k. That 2k will cancel and what will be left is 2k minus 5. Okay, so this is anyways positive. This is anyways positive. This also has to be greater than 0. Okay, this factor has to be greater than 0. Okay, let us see whether this factor can be, how it can be greater than 0. Okay, so what is that factor? Let me pick it up once again. I have 10k minus of 25. 10k minus of 25 minus 20k square has to be positive. Okay, has to be positive. Okay, or if I convert to the positive power, so I can write it as 20k square, or first of all, 20k square plus 25 minus 10k, this has to be negative. Okay, I've taken the minus sign then. Okay, or if you cancel with 5, the 4k square plus 5 minus 2k should be less than 0. Okay, should be less than 0. Now, if you make the equation out of it, okay, suppose if it was quadratic equation, 4k square plus 5 minus 2k equal to 0, what roots you will be getting here? Okay, I should write like this now. I should better write like this, minus 2k and plus 5. Okay, minus 2k and plus 5. So what is the k you will be getting? It will be minus b plus minus root over b square. Okay, right, that's not going to come up because it will have some complex number or what? Correct, it will be definitely having the complex root. Okay, because it's b square minus 4ac. Okay, minus 4ac divided by 2 into 4. So, okay, so this will not be solvable because it is complex. So, what I will only show you is, okay, take any value k greater than 5 by 2. Okay, if you take any value k greater than 5 by 2, that is required here. Okay, suppose I take k equal to 3. Suppose if I take k equal to 3. Okay, now you see here, you try k greater than 5 by 2, that is example k equal to 3. Okay. because that inequality is not going to be solvable because there are complex root coming up. Okay, I'll treat it like this. Okay, so if I put k equal to 3 here, so see 10 into 3 30 minus 25 minus 20 into k square, minus 20 into k square. Okay, so that is 9 minus 180. This is going to be negative only. Dear, this is going to be negative only. It cannot be positive. Even if you try for the boundary value, okay, even if you try for the boundary value, let me take it actually the boundary value 2.5. Okay, worst case boundary value also if I take now, how much will be this value? 10 into 2.5, 25 minus 25. Okay, minus 25 minus 20 into some positive number. So this is again negative. It cannot be positive. That means there is no common value of k. There is no common value of k where all the three can be satisfied. So it is unstable for all values of k. It is unstable for all values of k. That is for sure. Then it is unstable for all values of k. Correct, na? It is unstable for all values of k. That's not going to match it out at any cost. Okay, that is not going to match it out at any cost. Done. Okay, dear. Yeah, so it is unstable for all the values of k. Option number A would be the correct one. Okay. Next question then. This, we were stuck with complex roots. Okay. Yeah. So anyways, we left that inequality. We tried it directly. Come up here. A unity feedback control system has the forward part transfer function. Okay. GS equal to K upon S, S plus 2. Okay. Let me write this more clearly. This is given to you. GS is equal to K divided by S into S plus 2. GS equal to K upon S, S plus 2. If the design specification is that the steady state error due to unit ramp input is 0.05, what is the value of the gain K? If the design specification is such that the steady state error due to unit ramp input is 0.05, what is the value of the gain K? What is the value of the gain K? Simple question. Okay, steady state error. See, basically unity feedback, very clearly they mentioned unity feedback, so we can define the type of the system. Number of poles at origin is 1, S power 1, so it is type 1. It is S power 1, so it is type 1. Correct. It is type 1. Now steady state error due to ramp input, because it is type 1, so that steady state error will be given by 1 upon kV, velocity error coefficient, and that is given to you as 0.05. Okay, so kV is 1 upon 0.05, that should be 20, 100 by 5. kV is 20, clear na? Then you know what to be done. Come on, tell me the answer quickly. Half of the question or majority part of the question is solved. What is kV? Velocity error coefficient. Write down the formula for velocity error coefficient and then you can complete the answer for this. Yes. 22, correct. So let us see what is the answers given by you. Okay, kV is 20. Okay, but what I need the final gain K. What is the value of the gain K here? Okay, what I need is K, not kV. Okay, so let's see. Sai Vikas says C, Sai Bhargav says B. Okay, Gnanendra also says 20. See, kV may be 20, but K may not be 20. Please be clear. Okay, please be clear. Okay. Okay. Okay, let's do it. Let's do it. Answer would not be 20. Final answer would not be 20. Okay, so what is kV? kV is given by the formula limit of s tending to 0, s into gs. Okay, that is limit s tending to 0, s into gs, k upon s, s plus 2. Okay, s cancelled, and when you put s tending to 0, you left with k by 2. Okay, so kV, which is k by 2, is 20. So what is k? Is 40. What is k is 40? Option number C. What is k is equal to 40? Option number C is the correct one. Option number C is what is the very correct answer. Okay. Option number C is the correct one. Okay, done. Next. Okay, let's move to the next. Option number C. Yeah, now correct, Sai Bhargav. Okay. Okay, yeah. So these were the questions. These were the questions I collected from the PYQs of control systems. Okay. So later on, if you want more sessions around more subjects, so do mention in the comment box later on. Okay, so that based on the students' interest and demand, we'll plan some more sessions. One more definitely I'll try to plan at least for reasoning, because that has a good weightage. So one session around the reasoning questions also I'll plan. Okay, so yes guys, for the GATE 2026 EEC, okay, the new offline batch, okay, at our Hyderabad center starts April 7th. Yes, and next 4 days coming April 7th, the next batch starts. And for any more details, you can visit our center directly, or you can contact our support numbers. The fee is currently priced at 54,999. Okay, 54,999, and then there are some special discounts which are clearly mentioned in front of you. Also, the new offline batch for the AE exams, AE and AEE examinations, okay, for AP Transco Discoms or for Telangana Transco Discoms, that also starts April 7th. Okay, that also starts April 7th. Okay. Right, for GATE, if you can't travel for the offline course, if you can't travel to Hyderabad, so you also have the option to get the online live course, okay, wherein all the same faculties will be guiding you. Okay, and the fee for GATE 26 with 1 year validity is 19,999. For 2 year, that is GATE 2027 2-year validity course is 28,999. Right, so also, as I mentioned in the beginning, let me again mention you that for all the OM online courses, this live as well as the recorded course, there is this flat 20% discount on the occasion of the festival of Ugadi. And this offer is applicable till 5th of April. Yes, so take the benefit, use the coupon code Ugadi20 while purchasing any of the online course of OM. Okay. Right. That's it from my side. And yeah, I'll share you the PDF of whatever we discussed today. Okay, in my Telegram group. This is what is my Telegram group. Okay, you can search using this name. You can search using this name. The link is mentioned. Okay. Right, and I'll share you the PDF of this in my Telegram group. Okay. Of course, as a rule, all my PDFs are password protected. We'll keep a simple password. Okay, because if you are watching the session, then the PDF is there for you. But that then only you need the PDF. Okay, and I'll keep the simple password, that is BHEL. Simple. We'll keep a simple password for the PDF, and that is BHEL. Okay, dear. Okay, so bye bye. Thank you. Stay connected. All the very best for the examination, and see you in another session.